Welcome to ePG Pathshala lecture series on computer science. In this module on data analytics, we will be discussing about association rule analysis. Association rule analysis we will be analyzing in two parts. As part of the first module, we will be understanding the basics of association rule analysis, followed by knowing about the applications of association rule analysis, and then get an insight about a priori methodology for deriving association rules from transactional databases. Now, let us start with what is association rule analysis and some fundamentals related to association rule analysis. To start with, we should first understand what is an association, how it is applied in analytical environment. So, for this we should know what is association rule mining. Suppose there is a transactional database and assume there are many items that are being purchased or present in the transactions. There may be a pattern that co-occur and which is also often here in the sense occurring very frequently in the transactional environment. Then such frequently occurring item pairs or entity pairs can be detected and used for any further analysis. So, the process of finding frequent patterns, associations, correlations or any causal structure among set of items or objects in transactional databases or relational databases and then using it for further analysis. This entire process is called as association rule mining. To be very simple, it is fundamentally identifying association between item pairs that occurs in various transactional environment. Let us take a look at few examples. You can consider a rule of the form body implies head. What is the meaning of the rule is, suppose if there is an entity called body, then it implies there must be a presence of head. Now, this rule can be treated as an association, a representation of the association between the two items or entities body and head. Now, whenever you identify a pattern like this which indicates association between two or more entities, then that rule must be supported by means of two metrics. One metric is called as a support, another one is called as a confidence. We will be discussing about these two metrics in the later part of this lecture. As of now, let us take another example. For example, consider a predicate buys that is associated to an individual X. Assume the individual X is purchasing or has bought shaving razor. Then it implies the same person X may also purchase a shaving gel. Here the support and confidence value are 0.5% and 60%. The 0.5% here indicates it is the evidence which is available in the database, that is the transactional database, and 60% indicates the chance of shaving gel to be purchased given shaving razor has already been purchased by the person X. Let us take another example. Consider a student X who has taken the major computer science and the same student also takes database as a course. Then it implies the same person may get a grade A and the support is 1% and confidence is 75%. So, the 1% over here indicates the evidence from the existing transactional environment and 75% is a conditional probability which indicates the chance for a student to get grade A given the student's major is computer science and has taken the course database. Now, how these associations are discovered? There is a model called market basket analytical model which is often used for supermarket shelf management. The goal of this model is to identify items or item pairs that are often purchased together by significant number of customers. The approach which is used as part of this model is you will have to take the sales data, process the sales data and collect those items or product keys that has occurred often together in the transactional environment, and the items that have occurred together indicates some form of dependency between the occurrence of one item and the other item. Now, a classical rule For example, from such a sales or transactional database can be, if a particular person or someone buys a product called toothpaste and brush, then the same person is likely to purchase, say, a mouth cleaner. This is actually a kind of inference that you can derive by means of this market basket model. This association rule discovery or analysis has been widely used in retail domain, and many applications of association rule mining have been there in the history till date. Now, let us understand this market basket model in detail. Consider you have large set of items, that is the items or the products that are sold in a supermarket, and you have a large set of baskets. Baskets are nothing but, say, consider you are going for a supermarket, you are going to collect all the items from various shelves and then place them into a basket and bring it to the point of sale terminal, and inside the basket you may contain n number of products. So, basket as such may indicate a small subset of items that has been selected from the shelf, that is the retail outlet shelf. Now, what is that you are going to do is, you are going to analyze these baskets and then understand what are the items that are purchased together. The items that are purchased together are indicated by means of association rule. For example, people who bought X, Y and Z items together may also purchase item V and W together. Let us take this transactional example. Consider you have 5 transactions in your database. Every transaction is associated to a basket, and each basket contains some set of items that is available in the supermarket. In the first basket, we contain items like bread, biscuit and milk. In the second transaction, that is a basket, we contain items like sugar and bread and so on. Now, from these set of transactions, we can effectively or easily identify the associations between various items. These associations are indicated in the form of rules. For example, if a particular person has purchased milk, then there is a chance for the same person to purchase biscuit. Why this rule has been derived is, from the 5 transactions you can find biscuit and milk occurring in many transactions. For example, in transaction 1 you have biscuit and milk, then in transaction 3 you have biscuit and milk, and then in transaction 5 you have biscuit and milk. Out of 5 transactions, 3 transactions comprises of the items milk and biscuit together. Therefore, you can derive a rule stating, if a particular person purchases milk, then there is a chance for the same person to purchase biscuit. Similarly, another rule, if a person purchasing coffee powder and milk, then there is an implication that the same person may purchase sugar together. Now, what is the overall idea behind discovering such rules? One simple application can be a market shelf management. For example, consider you have items that are nothing but the products that has been selected, and baskets containing the set of products that are brought to the point of sale terminal. So, in a retail market basket environment, when you run this market basket analysis, you can typically identify who are all the potential customers for a particular product, and you can also identify what are the products that need to be placed in the same rack. In the previous example, we found milk and biscuit being purchased together. So, what is that the shopkeeper can understand is, if milk and biscuit can be placed next to each other in the retail outlet, there is a chance for milk and biscuit to go often as part of various transactions. So, such things can be easily identified, and accordingly the retail outlet can be managed, the shelves in the retail outlet can be managed. Another example wherein you can find such associations may play a vital role is, say, online web portals or online transactional environments where various items are sold. Amazon, for example, if Amazon wants to recommend some product to a customer, then Amazon has to go through its transaction, identify how many products were seen together or browsed together, or what are the products that were purchased together by the customers. So, Amazon can say, if some set of people have purchased item X and item Y together, and now currently if one customer is viewing or browsing item X, then below item X they may provide a recommendation like the items that may be sold together or the items that may be in interest to the user. Likewise, they can display item Y. Now, this is nothing but identifying association between X and Y by means of taking a look into the transactional environment, identify how many such pairs of items have occurred together and accordingly provide recommendations. Now, consider text domain. In text domain, you can treat the same basket comprising of various sentences and items indicating the documents in which these sentences are available, or even you can treat words as baskets and the documents in which these words occur as items. Then what is that you can do is, you can easily identify what are those items that occur together here in the sense, those items here in the sense the documents that are similar to each other. Now, how you can define this? If you can take the sentences, you can identify in which documents these sentences are available. Based on the frequency of occurrence of certain documents together, you can easily predict, suppose if a particular person is browsing through a web page 1, what is the chance that another person may browse say the another web page. So, you are trying to derive interrelationship between two web pages, and hence accordingly you can reorganize the various pages available in a given website. This is another application of a priori approach. Let us take healthcare domain. In healthcare domain, we can consider various patients as baskets and items as the set of drugs and side effects. Now, what is that you can do is, you can easily detect combinations of drugs that results in various or a particular type of side effect. Therefore, if you want to prescribe a particular medicine, with the help of the association rule, you can even prescribe a counter medicine that will suppress the side effect of the previous medicine. But this actually requires various extensions here in the sense, if suppose an item is completely absent in the database, then it may not be available in the association rule. So, in general, what is that we are trying to view? We are actually trying to visualize the many to many relations which is called as association between two kinds of thing. One is the items, but actually speaking we are not trying to identify association between baskets. So, the objective is to identify association between items. For example, if you have Twitter data, for example the various tweets, what is that you can do is, you can identify communities that talk about a specific topic. Now, for this what is that you need to do is, you need to consider the basket as set of nodes. Nodes here in the sense, say the users, and the items are those users who are connected to say the users in the baskets. For example, if I am tweeting, I will be one user, there may be a friend associated to me. So, therefore, I myself will be treated as a basket, and all friends of mine will be considered as say the item sets. Now, what is that I am trying to do is, I am trying to identify say a complete bipartite graph that will help me in visualizing a specific community from my Twitter data set or from any social networking data set. Now, how this can be understood? Say, all that you need to do is, you need to visualize the entire social networking data in the form of a graph. Now, what is that we are trying to do is, we are trying to view each node I as a basket that comprises of nodes that point to it. So, this red dot can be the various items as part of the basket, and we are trying to identify who are all the other nodes who are connected to this particular node. We are actually working towards a subgraph which is called as a bipartite graph. So, we all know bipartite graph can be of comprises of two subsets, and both the subsets are connected to at least one element in the other set. So, we are trying to identify K, which is a bipartite subgraph that has at least one link to the other set. So, looking for such a bipartite graph is once again a problem of identifying frequent item sets. Now, when you want to understand association rules or association rule analysis, we should have some understanding about the basic concepts or terminologies related to association rule analysis. The first thing is, we should understand the definitions for frequent item sets, association rules, the metrics which we discussed at the beginning of this lecture like confidence and support, interestingness, etc., followed by a detailed understanding of the algorithms that may be of useful for deriving frequent item sets. One commonly used and very famous and well established algorithm is a priori algorithm. Now let us define what is an item set. Item set is actually a set of items identified from the transactional database. For example, a set need not be null here in this scenario, because when there is a transaction, the transaction will surely have at least one item. Therefore, the item set is not going to be null here. Suppose an item set comprises of k items, then it is called as k item set. For example, consider the set bread and jam. The number of entities participating in the set bread and jam is treated to be a 2 item set because there are exactly 2 elements in this set. Now, every item set can be associated to an occurrence frequency, which is the number of transactions in which these item sets have occurred. If suppose you fix a threshold called minimum support, the minimum support indicates say a count. The count here indicates the minimum number of time an item pair should have occurred in the transactional database. Suppose if an item set satisfies this minimum count, minimum support count, then you can consider that item set to be a frequent item set. In other words, an item set that satisfies minimum support, it is called as a frequent item set. So we have discussed about item set, k item set, and when a frequent and when an item set can be frequent. Consider this example. You have set of items like milk, Coke, Pepsi, bread and juice. Suppose if the support threshold is 3 baskets, that is the items must have occurred minimum in 3 baskets or in 3 transactions. B1 till B8 indicate the various transactions, and the notations M, C, B and P indicates milk, Coke, Pepsi, bread and juice respectively. So these B1 till B8 indicates the transaction and the items which has occurred in those transactions. Now to identify the frequent items, we will have to take all the individual items milk, Coke, Pepsi, bread and juice. Then you will have to identify whether it satisfies the minimum support. That is, if an item M should be a frequent item set, then it must have occurred in at least 3 baskets. Now let us take the item milk. If we go through the transactions, you will find item milk has occurred in 5 transactions, therefore it satisfies the minimum support and hence it can be considered as a frequent item set. Similarly, Coke, bread and jam, but the item called Pepsi is not considered to be a frequent item set because it has occurred only in 2 transactions, that is B5 and B6. Since it is not satisfying the minimum support, we cannot consider Pepsi as a frequent item set. So that item set will be dropped. And we can have item pairs like M and B, that is milk and bread. Milk and bread, why it is considered to be a frequent item set is it has occurred in 4 transactions, therefore it satisfies the minimum support. Then you have another item pair bread and then Coke. Bread and Coke has occurred in 4 transactions, and at last Coke and Coke and juice has also occurred in 3 transactions. So these transactions, these item sets have occurred minimum 3 number of times and therefore they are considered to be frequent item sets. The item sets that comprises of exactly one element or item are said to be one item set. The item sets that comprise of exactly 2 items are considered to be 2 item sets. So as a result, we find 4 single item set and then 3 2 item sets that are frequent in nature. Now with respect to a given rule, I told every rule will be associated with a support and then a confidence. Support is actually the probability of the transaction to contain both the right hand side and left hand side of a given rule. For example, if you have a rule x and y implies z, then support is the probability that comprises of the transaction which contains x, y and z, that is combination of the LHS and RHS of the given rule. What is confidence? Confidence is actually a conditional probability. The conditional probability indicates, given the LHS, what is the chance for the RHS to occur. That is, it is nothing but the conditional probability indicating that transactions having X and Y also containing the item Z. Let us take an example and understand this support and confidence. Consider here there are 4 transactions with various items. Now, if the minimum support is 50% and minimum confidence is 50%, we can derive a rule A implies C. Now, for this rule, if you want to derive the support and confidence, then support, as I already mentioned, it is the probability of occurrence of A and C together. From the given set of transactions, you will find A and C has occurred together in 2 transactions, that is transaction ID 2000 and 1000. So, probability is number of favorable events divided by total number of events. Number of favorable events here is 2 transaction, total number of events is 4 transaction. So, it will be 2 divided by 4, which is 1 by 2, which is equal to 50%. Now, let us take the confidence. Confidence, as I already mentioned, it is a conditional probability. So, here we will have to consider the probability of A and C to occur together divided by probability of A. Probability of A and C to occur together is nothing but the support, and probability of A is A has occurred in 3 transactions. So, probability of A will be 3 divided by 4. So, probability of A and C is 2 divided by 4. The probability of A is 3 divided by 4. So, 2 divided by 4, the whole divided by 3 divided by 4, which is equal to 66.66%. So, the support for the given rule is 50% and the confidence for the given rule is 66.66. What does it mean? From the transactional environment, you can understand A and C has occurred 50 number of transactions in 50 transactions if there are 100 transactions. The confidence indicates the chance for C to be purchased given item A has already been purchased. So, the chance for C to be purchased is 66.66% given item A has already been purchased. This is what you can infer from a given rule and the corresponding support and confidence metrics. Now, association rules may contain more than one item. So, when you want to work on the rules that works on multiple items, then you will have to identify is that rule is really interesting. A particular rule, though may be highly supportive and though may be highly confident, it may not be interesting. The reason is part of the elements in the given rule might have occurred n number of times, that is large number of times. But the interestingness of a given rule is what matters when you are going to take a decision. So, we will have to work not only on support and confidence, we should also work on the interestingness of a given rule. Interest of a given rule is defined as the difference between the confidence of a given rule minus probability of the item which is on the RHS of the given rule. For example, if the rule states I implies J, then the confidence of I implies J minus probability of J, where J is on the RHS of the given rule. Now, let us take an example. Here we have the same number of transactions B1 till B8, which we used for identifying frequent 1 item set and 2 item sets earlier. From this, let us consider a rule M and B implies C, that is purchase of milk, bread implies Coke. Now, the confidence for the given rule is 2 divided by 4. 2 is the number of transactions in which item M, B and C has occurred together, divided by 4 is probability of item M and B together, which is equal to 0.5. Now, interest is the difference between the confidence and the probability of the RHS, that is the item in the RHS of the given rule. So, confidence for the given rule is 0.5 minus probability of the item C. Probability of the item C is number of transactions in which item C has occurred divided by total number of transactions. Totally there are 8 transactions. Among these 8 transactions, in 5 transactions item C has occurred, that is B1 B7, B4, B6 and B8. So, the probability will be 5 divided by 8. So, which is equal to 1 by 8. Now, when you take a look at the value of confidence, confidence value is larger when compared with the interest value. Therefore, you can say that confidence, though high, the rule is not highly interesting. When you try to find the association rules, now what is that you need to do is, the hardest part over here is identifying the frequent item sets. Identifying a frequent item set sometimes may result in a very large number of combinations, and these combinations sometimes could not be held in the main memory. Therefore, computing all possible item sets, calculating the frequency of all these item pairs sometimes seems to be a difficult task. Now, how this can be overcome? For this, there is a methodology called as a priori algorithm, which is often used for extracting single dimensional Boolean association rules from transactional database. For example, if there is a transactional database like this, all that we need to do is, we will have to fix the minimum support and confidence and then identify frequent item sets. After deriving the frequent item sets, then you will have to derive all possible rules for these frequent item sets. So, the working principle of the algorithm called a priori algorithm is, whenever you find a subset of frequent item set, then all subset elements or entities in that subset can be treated to be frequent. In other words, you can take a look at this from a bottom up approach. There will be a universal set. Assume if the universal set is frequent, then it indicates all its subset must also be frequent. That is the meaning of it. So, how this can be identified? A priori algorithm actually runs in two phases. One is the join step, another one is a prune step. In join step, we will be generating various candidates, and these joined candidates will be verified for whether it is frequent or not. If it is frequent, then we consider the item, else we ignore it. So, joining step is generating the candidate sets, and pruning step is looking for whether the joined candidates are frequent or not. So, when you take a look at this algorithm, it indicates that every candidate that you are generating from the given set will be considered for its frequency. For frequency here, in the sense, its frequency will be counted first, followed by whether it satisfies the minimum threshold or not. If it satisfies the minimum threshold, then it will be appended to the frequent item set. So, here in this example, there are 4 transactions. From these 4 transactions, various item sets as candidates are generated, and from these item sets, the frequent item sets are generated. At last, we find one item set comprising of 2, 3, 5 to be the highly frequently occurring item set, because it satisfies the minimum support 2. So, to summarize, a priori or identifying frequent item sets in the real world is something that happens often. Identifying such item pairs and using it for decision making in business scenario becomes very vital, and identifying associations between such item pairs is done very effectively using a priori method. Thank you.